Now the last thing here that we're going to see is De Morgan's laws for working with symbolic logic. We're going to start with our components P and Q, and if we look at taking the negation of a conjunction, that is the negation of a statement of form P and Q, much like what we saw in sets, we're going to flip each part and then flip the thing connecting them. So the negation of P and Q becomes not P or not Q. And similarly, if we negate P or Q, we get not P and not Q. And to understand this, we can look at the truth table for this sort of setup. We can look at the truth table for this sort of thing. In the first case, what we'll have is a whole lot of writing on things we've seen before, but that's okay. We've got our main options, and within it, for P and Q, the basic conjunction, we will get true and then a whole bunch of falses. And then if we negate each piece, we take the negation of P and the negation of Q. Hopefully you're fairly confident, even if you're not quite as confident as I am right now and can somewhat keep the pace. We would get false, false, true, true, and false, true, false, true. So, if we were to take this and look at the conjunction, the disjunction between them, not P or not Q, what we would get is a statement that is false, true, true, or true. Meanwhile, if we were to take this statement here and negate it directly, that is, take the negation of the conjunction P and Q, we would get a statement that is false, true, true, and finally true, which tells us, based on our main idea here when we're looking at truth tables to establish equivalence, that these two statements are equivalent. And this tells us something else. We can use this to talk about our work with negations of conditionals as well, to get a nice relationship for a way to describe conditional statements without using the conditioning, because we have this relationship to start with. The negation of P implies Q is P and not Q, as we saw just before. So, if we negate this, we look at the negation of if P then Q, well, those negations cancel out. If you take the negation twice, you get the original statement. We get P implies Q, while on the other side, if we negate this, we get not P or Q. So now, we can say that the statement if P then Q is equivalent to the statement not P or Q.